Consider analyzing your Chapter 2 experiment data. I just want to speak for a few minutes about experiment 1.8, which was the experiment where you had the graph paper and you found the sensitivity of the balance, and we also measured a stopper repeatedly on each of the balances, and then we massed a 200-gram mass repeatedly on multiple balances. And from all of that data, we compiled all that data in this worksheet that you see here. And this present page, if I can read here, because I'm being a little, can't quite see behind the icon here, is the chemistry balance. The chemistry balance data for the stopper fluctuates from 13.53 grams to 13.54 grams. So that's only a swing of 0.01 grams. Whereas for the 200-gram mass, the balance fluctuated between 199.98 grams and 200.04 grams. So that's a range of 0.06 grams, which is the difference between the maximum and minimum values. So those values don't mean too much in isolation. So let's compare those numbers, the range, to other balances. So if we click on the Flynn balance and we look at the statistics for that, we see the range of the Flynn balance is greatest for the 200-gram mass, and it's awfully small for the mass of the stopper. Physics balance, very similar. The range is much greater for the 200-gram mass, much less, in fact, 0.00 for the mass of the stopper. And finally, the number one balance follows that trend. The range is greater for the 200-gram mass than it is for the stopper. However, it's a much smaller difference than the other balances. So at this point, we need to consider the big picture. So as a scientist, how much can you trust your balances? How much should you trust your balances? And for that, I would say that scientists want to play their data conservatively most of the time. So scientists never want to be accused of tweaking the data to suit their needs. So for that reason, scientists they play it safe. So if we were to play this data safe on this spreadsheet, we would have to say that we only trust the balances as much as the least precise balance, right? Similar to what we had said a couple weeks ago about measurements. So a chain is only as strong as its weakest link, and then the significant figure rules that we talked about. So if the balances are only as trustworthy as the least trustworthy balance, we need to look at the least trustworthy balance. Well, the chemistry balance is only trustworthy within 0.06 grams for the 200-gram mass. The Flynn balance is only trustworthy for 0.07 grams. The physics balance is really only trustworthy within 0.07 grams. And the number one balance is trustworthy within 0.04 grams. So worst case scenario, I think we can say that our balances will give us reproducible readings within 0.07 grams. Again, we're being very safe there. If we wanted to, we could analyze all of our Chapter 2 experiment data by looking at the balances that the data was collected from, and we could consider the trustworthiness of each balance separately. So we would look, for example, at the data from experiment 2.1 that was taken from, for example, the Flynn balance, and we can apply its error or its range to that specific data. But that would be pretty cumbersome. So I suggest that we treat all the balances as one group of balances, and we'll say for all 4 balances, we trust them to give us reproducible measurements within 0.07 grams.